Hello everyone, as I mentioned in last video, this video will be about Android fuzzing, and I will make the name of this video as Android fuzzing overview 1 because there are a lot of things to tell about Android fuzzing, and maybe later I can show you how I write those fuzzers and how you actually implement those fuzzing techniques. But I have to mention that I cannot tell you everything I know because there is some work belong to my company since I'm doing an internship in China Macro. So yeah, I actually prepared a PowerPoint, but that was for my colleagues, and yeah, I cannot publish right now. Maybe sometime later. Yeah. So basically, Android fuzzing is a quite hot topic, and many people are doing this, and there are, I think, many projects in GitHub, and you can find all those things. And today, let's talk about for fuzzing we have active fuzzer and passive fuzzer. So active fuzzer is something like this. You get a target and you just input some random number or random data, random buffers into that target, and that is active fuzzer. And for active fuzzer, you have some other tricks, like you have to change the input according to the response of the target. That is something like dump fuzzer, mutation fuzzer, or revolution fuzzer, and other things. And yes, for active fuzzer we have XYZ color here, and and we have this Android AFL. This guy is people in a company in China, which is 360, and this project is for AFL on Android, and you have to compile this Android AFL in AOSP, and yeah, actually I think he mentioned how to compile this, and the basic idea is that in Android you use hash memory, and in Linux use shell memory. So the key point in this project is that you have to implement this hash memory, right? So yeah, with this you can just compile this Android AFL, and I think you will get a AFL fuzzer, and for the rest you can think of a ways and how you can use this to fuzz some targets on Android. Yeah, this Android AFL, and yeah, basically. So for AFL, there are many things to say because AFL is a very powerful tool. So the basic idea is that the instrument, the AFL actually insert some instruments into the code, and you can use those things to record the kernel coverage, and with the kernel coverage, you know that the AFL can like change their input and all those things. Very powerful, and yeah, I can tell something about AFL, and with AFL we have QEMU mode, right? And QEMU mode is like a dynamic instrument, which means that you don't have the source code, and in the QEMU mode you can instrument those insert those instrumentation when it's running. I think it's in the assembly code. Yeah, and for those targets that you have the source code, you can use AFL GCC or AFL clone, and to compile the source code, and it will insert those instruments while it's compiling. So the idea is that the AFL fuzzer is actually going to fork at first, and he will get a fork server, right? Yeah, if you use AFL, you will know that fork server, and the fork server is like communicate with AFL father. So AFL fork server is going to fork again, and it will get another child, and in the child, it's actually doing all those code, running all those code, and the fork server is communicating with AFL father in a shared memory. So in that shared memory, it will tell the AFL father about the kernel coverage and all those things. Yeah, and how the kernel coverage information is recorded in that shared memory. That's very interesting because you can dive into the FL source code, and you will see that it actually used trampoline, and it will get a random number for every piece of code, and yeah, when the code is hit, and it will take that number and yeah, put that in a shared memory, and actually finally you will get all the code coverage information. So that's the basic idea about AFL fuzzer. And with AFL you have something else like AFL dynasty, like AFL unicorn, and yeah, so many things you can yeah, that's very powerful. You can just dive into learn more about that. And for Android AFL, that's it. And for XYZ caller, this is also a active fuzzer. So what's powerful about XYZ caller? Yeah, you can actually find Google provide this tutorial for building a pixel kernel with constant and kernel coverage. So I've mentioned the kernel coverage before, right now. Oh, okay. So that's kernel coverage. I'm not going to tell that again. So for Carson, it's like kernel address sanitizer. What's this? So kernel address sanitizer is something like yeah, to actually tell you here. Yeah, so Carson is actually use some like shadow memory to record that that some memory is not accessible, and when that memory is accessed, it will give you an arrow and tell you that you cannot access that memory. So yeah, this is kernel address sanitizer. So basically with pixel, and you can build a pixel kernel with constant and kernel coverage. But I think pixel kernel is 3.4, right? At least it's above 3.1. So you cannot build 3.1 with constant kernel coverage. But I do see some people build a Linux kernel with version 3.1 and with constant kernel coverage, but I don't think they build that with Android kernel. And if you want to build the constant and kernel coverage, make sure that your kernel is above 3.4. And yeah, I think someone put constant and kernel coverage back to 3.18. I think I do find someone say that said that they put that back to 3.18, but if you want to do that on real device, make sure that you do that on a pixel kernel. Yeah, so why do I mention this? Because with SY caller, you have to provide a kernel coverage and constant to make it much more powerful. So this is what makes SYZ caller special, is that you need to provide a sample for SYZ caller, and that sample is something like for open, you have to open something, right? You have to input some arguments. So for SYZ caller, you have to provide a sample that not the sample, but just like you have to provide it's provided something to tell it how to fuzz that syscall, so it can save some time. Yeah, I think yeah, I think that's all for as well as the color, and you can find more on your own, because yeah. So for passive father, right? Yeah. You can see this project in GitHub, and yeah, he's my mentor. He is very professional, and he's very willing to tell you about his knowledge and all those things. You can find this passive father here. So basically, the idea is that you change the kernel function. So a kernel function like copy from user, right? I think this father just changes that copy from user. You change that function and you change the input from user mode, right? So you change that and you just mutate the input, and every time a syscall happens, every time a copy from user function happens, you change the input. You actually fuzz once. So yeah, this is actually a passive father. So personally, I just prefer passive father because it gives you much more kernel panic and also things. So yeah, this is very powerful. You can check out here. This is a project for my from my mentor Mooney. Yeah. So okay. Is there anything else? Let me think about. There are many things to tell, and the passive father, active father, and yeah, there are some other fathers like app father. I do find some project in GitHub. I think it's named Jode app or something. Yeah, it actually uses some intent to launch an application like a PDF reader, and with the PDF file you can like get actually fast one file every time 10 minutes 10 seconds. Yeah, quite slow. And there's also something like NFC father. Yes, so the device that on your phone that you are going to pay the money, you will use the NFC. So that's NFC father, and there are many other fathers. Yeah. Let me think. Are there anything else? I don't. Yeah, I just cannot remember everything. So yeah, that's all for it today, and maybe sometime later I will introduce how I'm going to write a Android father, and actually just show you the code, or maybe sometime I will publish my code and put that on my GitHub and show you all those things. Yeah. Is there anything else to tell? Yeah, actually, security is quite interesting, and that's what I spend most of my time. So I think these days I spend 7 days a week in the company, and above 12 hours in the company. I just find it quite so interesting, and I just cannot stop doing all those things. So I hope you all enjoy my video and enjoy the security area. No matter what your focus are, maybe web, maybe Linux, maybe Windows, or maybe iOS, Android. So many things, and just keep going, keep move on, and never give up, because that's your dream, and you want to achieve something, and you have to go on and go on. Yeah, this Android fuzzing. Maybe next time I will do something. Maybe go just deeper into Android fuzzing, or I think maybe something else. Okay. See you. Hope you all have a great day.